Alright guys, welcome to day 16 of Advent Code. Before I begin, I do want to give you guys an update on yesterday and day 15 because I didn't solve it. I want to update you now that I did solve it. I did figure it out. My A-star solution was a bit over needed. Dijkstra's algorithm, which is basically what the base of A-star is built upon, is all you really need. So my code is up on GitHub if you really want to look at it. It is working now. I got both parts, so thought I would update you guys on that and tell you basically Dijkstra's algorithm, which is what I used to solve this, was really all is needed. So was on the right path, just wasn't quite there. Luckily I did get in the end with some help from you guys, so thank you very much if you helped me out. But anyways, day 16 is about to begin. 40 minutes, so I'm a little bit early, so I will cut to when I begin. But yeah. Alright, and here we go, day 16. Let's go ahead and grab our puzzle input. This looks fun. This looks like hexadecimal, if I had to guess. Let's see what we got. As you leave the cave and reach open waters, receive a transmission from the elves back on the ship. The transmission was sent using buoyancy interchange transmission system, or bits, funny. A method of packing numeric expressions into binary sequence. Your submarine's computer was saving the transmission in hexadecimal. The first step is decoding the message is to convert the hexadecimal representation in binary, each character, whatnot. Makes sense. The bit transmission contains a single packet at its outermost layer, which itself contains many other packets. The hexadecimal representation of this packet might encode a few extra 0 bits at the end. These are not part of the transmission and should be ignored. Every packet begins with a standard header. Okay, so this is kind of parsing. Okay, this is my type of thing here. First bits are the packet version, next 3 bits are the packet type ID. These 2 values are numbers. All numbers encoded in the packet are represented as binary with the most significant bit first. Example, reference number 4. Okay. Bits, okay, so it's the version, T, which was type. The 5 bits labeled A start with a 1, not the last group, keep reading, and contain the first 4 bits of the number that. The 5 bits labeled B start with 1, and contain 4 more bits, okay. C, and 3 unlabeled, and the extra hexadecimal. So this packet represents a literal value with binary representation, which is 21 decimal. Every other type of packet, any packet with the type ID other than 4 represents an operator. Okay, wow, this is a lot of reading. Let's just let's keep reading. Every other is an operator that performs some calculation on one or more sub-packets contained within. Right now, the specific operations aren't important. Focus on parsing the hierarchy of sub-packets. An operator packet contains 1 or more packets to indicate which subsequent binary data represents sub-packets. An operator packet can be used one of 2 modes indicated. The length type ID is 0. Then the next 15 bits are a number that represents the total length in bits. Holy. Okay, so there's a lot of kind of rules. Okay, after reading 3 complete subpackets, the number of packets indicated in L3 is reached, so parsing of this packet stops. For now, parse the hierarchy of the packets throughout the transmission and add up all of the version numbers. Okay. Wow, this is going to be interesting. So we're given this big giant thing in hexadecimal. Okay, so string hex inputs. So we have to break this up into bits and read each one. So every packet begins with a standard header. Okay, so we're gonna probably have to break this into methods. So it's gonna be public. We're gonna do, since left to right works, we're just gonna do it left to right. We're gonna be basically building methods that are gonna call themselves and bubble back up. Is what's gonna kind of happen. So we could, it's probably best to convert this into one long binary. I don't want to convert this all to a big giant string, but it should be okay. Let's do it. Okay, so for char c in hex dot to char array, I'm gonna go ahead and do builder append. Does Java okay. So you can do new big int. This is interesting. I'm gonna do this because this is interesting to me. C and then the radix 16 because it's binary, or not binary, it's hexadecimal. And then you can do toString and convert the radix. That's interesting. That's something I think I would see from big integer. Does this only work string int? Okay. That's fine, we can do this. So this will take the string. Oh wait, this will take the entire thing. Oh. I'm curious, does this do it? Like, just that? This is all new to me. I'm curious. I'm kind of, if this works, I'm gonna go use it because that seems cool to me. How fast is it? Oh, it's pretty fast. Okay, that works. Sure, let's use it. Why not? Okay, so we have our binary. How do we want to solve this or go about doing this? So we're gonna have to go bit by bit to pull off the relevant bits. So let's just start with, parse pack, let's just start with giving it the binary. We'll have to go through and kind of change it in the future, but so we're gonna have, this is the version, which is gonna be binary substring. Doing all these substrings is not what I want. I mean, that's just a long list. Let's go back to string. That's fine. Okay, it's not ideal. Let's go back to string. Let's just do it first, and then we can worry about making it better, I guess. So substring from 0 to 3. That'll give us the version. And then we need the type, which is the next 3. And we can actually do an integer parseInt on this. With given a radix of 2. So this is version. So this will now go from 3 to 6. Okay, so we have those two. And so now depending upon the ID, so switch the type, I guess. So if it is 4, we know what we're doing. I know what I'm doing. I should be doing. So back to string. Okay, so we do need a. All right, let's call this cursor. Okay, so it's going to be cursor plus 3. Okay. This will work. This is more of what I mean. We'll break this off in the future, I guess, but for right now, this is good enough. I might like break these individual things, but for right now, okay. Cursor, that works. So now we go to here. So we need to go while we need to grab the next number. If it's a 1, continue on. So I don't know. Public int read parts. Let's go with this. No, this needs to return that. Let's make cursor global. Okay, so I'm going to pass cursor around everywhere. Cursor can be done here. So read parts, we just need the binary and the length, and we can return. Actually, you can read parts. I can do read part int. This is, I mean, I'm going kind of overboard on doing this, but you know. Int num is no, it's fine, because this will do this string s is that, and then we need to do cursor this, and then return s. There we go. That's gonna be length. So what this can be is this can actually just be read parts int binary 3. Good. So we need so this is going to be read parts int, provide the binary length of 1, and then while start equals 1, continue to do this, and what we need to do is then is just going to be this, right? Going to be the next 4. Okay, and then we need to count the total. So it's going to start at 6, and then actually you can start at 7, and then every time this runs, we'll do total plus equals 5. We get our num, and then here, so then we'll do for int I equals 0 while I is less than total 4. Oh, no, we can just do extra is going to be read part this. That'll get the remainder of what's those numbers there. So that should read in correctly, hopefully, the first part. So that should get us this done. I won't worry about these numbers in here yet. This is fine. Okay, so if the length is 0, the next 15 bits are a number that represented the total number that represents the total length in bits of the sub packets contained by this okay, well, so case 0. What is this supposed to be? The next 15 bits. So this is int length. Let's break this off into other methods. So public void parse literal. Instead of parsing them all in that switch statement here, let's move them all into here. I could make binary not be passed around everywhere. Because it's gonna be just passed around everywhere. And it's not gonna be used by like anything. So let's just not pass it in literally everywhere. That's not needed. That's not needed. Oops. Okay. Okay. So it's to parse our literal. So now we need then to basically do the exact same thing, but so literal, what is it? Let's go op 0. Okay, so we need int length. It's okay, I misunderstood this. This is the length indicator is just read int 1. So if it's 0, 15, otherwise it's 11. So that'll read our length, right? Available to I. Should we have read that? So maybe, so maybe we would want to pass in the string and the cursor into these instead of doing this all by hand. I see. Okay, so this is the length, right? So that's gonna be the length. So it's 27 bits. 27, so 11 bits A contain the first subpackets. So I would need to know how long what I could do and then what I could do is then call a parse packet. I guess we could just do while cursor is less than start cursor plus length. We just go through and parse a packet, right? Yeah. Okay. So now we just need to add up the version numbers. Okay, so how are we gonna wanna? So this is where we kick it off by just parsing the packet, right? And we want to add up all of the version numbers. So let's just do public long part 1, I guess. And let's just do part 1 plus equals version. And then after this, we should be able to call lap part 1. And we should get an output of 7. Doesn't seem right. I bet you that toString doesn't do what I think it does. I bet you if I do B, that's not going to be, oh, not B, 6, sorry. Yep, there we go. Okay, so it's not, Okay, so I guess we're gonna do this then. So for string, okay, well, rather than try and play around with it more, let's just get this done the dirty way. String builder. So for char c in hex dot to char array, Let's do string. Can always do this. And then we can do, because this accepts binary. So I can do builder append. Builder, but I'm doing binary. Builder append, and I can do 0 repeat, and it'll be binary dot length. It'll be 4 minus that, because if it's 4, it'll be 2.0. Yeah, and then append on binary. And so now this hopefully builds it correctly. Better. I think that's not meant to be there. Oh my goodness. Okay. I see. Okay. Okay, let's do it this way. If length indicator equals 0, we gotta do some logic. Okay, I've messed this up. So this is if it's 0. So it's always gonna be 15, and then it's reading that in. Otherwise, it's gonna be still this, but it's gonna be length of 11, and this is going to be num packets. So for int IP equals 0, p is less than num packets, p plus plus. Is this going to give us the right answer now? 12. Okay. I see, I see. $9.20, that seems much more reasonable. Hey, there we go, part 2. Okay, now that your structure transition decoded, you can calculate the value of the expression it represents. Literal values type 84% a single number as described above. So packets ID 0 are some packets. So now I should use the types. Okay, so now I should do stuff with these numbers. That's gonna be fun, because I don't actually, I just kind of... Okay. Oh wait, no. Okay, no. This is returning an integer. But we need to do string builder build. Sure. So we're going to do builder append read part 4. Ignore the number bit. And then we get to here, we can return integer parseInt builder toString binary. Why are we reading the last 4? Because it should be that. There we go. Total's not needed. Thank goodness. Okay. So now whenever parse literal is called, so now we have a value. I mean, it's not, nothing's happening with this yet. But okay, so where am I? Where am I with this? Part 2. So 0 sum packets is the values of some of the values of the subpackets. A single sub packets, their value is the value of the sub packet, of course. Package to type ID 1 or product. Okay, so we have to go through on the opcode. So it's parsing the packets. So they're always going to turn an integer up, right? So we can just return that, can we? And just make everything return something up. Okay. I apologize for the train, so I might be train going really slowly. Okay, hold on. So packet with ID 1 is a product. Can you go faster, train? Goodness. So we actually grab type here. I guess we're going to give the type to this then. This is fine. Min, max, greater than, less than. Okay, so every time, so this is going to be a number. So actually what we should do is we should do int num here. Well, we can't do that, I gotta do everyone. Okay, so now we have to do... I don't know. We're gonna do this instead. No. But I don't like how the fact they're split is what I don't like. These are both split, and I'm really not happy with this. Because now I have to do this logic twice, and I don't want to do logic twice. So instead, okay, I should do sum. So, because it's gonna be int sum there. We can do this. We can do int to return. But we don't know. Okay, let's just get this done. We'll worry about cleaning it up later. So we can do a check here. If type is 0, to return plus equals number. Yeah, okay. One down. Product packets, the value results multiplying together the value of the sum packets. Okay, so now we can do this, but now we have to add a case up above. Do this then. Yeah, do that, it's fine. It's defaulted 0, it's fine. Okay. 2 are the minimum. And just going through. This is why this is gross to me. To return is going to be number is less than to return. If it is, it's going to be number. Otherwise, it's to return. Oh, it's going to make convert me to method min. Yep. Okay, that works. Okay. 3 is going to be max. So it's gonna be the opposite of this. Min value 3. And this is gonna be the opposite 3, but it's gonna be max instead. Oh, this is so gross. Type ID 5 are greater than packets. Their value is 1 if the value of the first sub packet is greater than the value of the second sub packet. Otherwise, their value is 0. Oh. I don't know how to handle greater than, less than, or equal to. We can't get a negative. Actually, that's what we can do. We can't get a negative. So we can do else if that actually works somehow. That's not, again, it's gross, but this works. 6, 7, and we're going to be giving it -1. Because again, we can't, the literal can't be negative, so somehow this actually works out. So what we do here is we do, so if to return is -1, that means we need to wait. So to return, if to return does not equal -1, then we need to do to return is, what's 5? Greater than? Oh, otherwise, sorry, equals this. Right. Because then we gotta set it. Okay. All right, and then this one is gonna be that, and then this one's gonna be equal. Okay. In theory, this should. Let's, fingers crossed we got this right. Return to return. Lap 1, and then we call lap of value. It does them both at the same time. That's fine. Please get this right. Huh? These need to be longs. Oh. Turn these all to longs. Okay, well, it's not work now. Please be right. I don't wanna. Oh, we're good. Okay, we're done. Wow. It's late. It's been an hour. It wasn't as bad. I made that a lot worse than it should have been. I just was very indecisive about this whole entire thing. I should have gone for it. But we got in the end. So let me go through, clean my code up real quick, and then I'll try and explain my solution. Hopefully it'll be easier once my code's cleaned up to explain this. So anyways, BRB. Okay, so this should be much cleaner now. I went through and I actually did this correctly of how I wanted to do the first try, and I just couldn't figure it out in the moment. But anyways, TLDR is that we are given this big long hexadecimal string, and we need to take that and do a list of series of instructions. This is basically kind of like a machine code type problem, sort of, I guess. But basically what we need to do is the first thing we need to do is take in our big long string of hexadecimal and convert it into binary. You don't need to do this. You could do, on a char by char basis. So take the char, convert it to binary and process that way. I just want to make it easier. I just want to take the entire hexadecimal string and just convert it to binary, just right there and there, make it easy. From that, so then we store that string in this binary string. We also have this cursor string. This tells us where we are in the string we are currently processing. And then we also have our part 1 version sum here. So that's what these 3 here are. And then from there we go and start processing the packets that the data represents. So to do that, the first 3 bits of every packet are the version. So we pull off the first 3 bits, which this just does a conversion here. So this will substring our binary at our cursor location, which starts at 0. So it'll start at 0. And it'll read the next 3, so I told it to read 3 bits. So it'll read the first 3 binary numbers out of this. It'll automatically increment our cursor to be past where we've read now, and then this parseInt will just convert that binary number into a regular integer number that will then get returned up here as our version. And then for part 1, we are just going through and just summing all the versions together. So that's why this part 1 exists here, is just to sum versions as we get them. And then for part 2, we actually go through and we process the packets. Well, you do for part 1 as well, but part 1 is a little bit more simplified than this. It's just dealing with for or not for. But for part 2, we actually go through and we do all of these. So what we do is we read the next 3 binary numbers, which is our type. Our type is then converted into what we are doing. The first type represents a parse sum. These all work basically identical, so I'll only go through a few of these. But what parse sum does is it obviously takes a sum, and then we actually parse the opcode here. So this is what I was trying to do earlier and I couldn't figure it out. But all of these parse the opcode, which is actually parsing the inner packets essentially. And they all return a list of numbers. This is all just number based. So I can actually probably condense this a little bit more and just do that. But so what we do is we read the next bits. The next bits of our packet here tells us whether or not we are reading 15 versus 11 bits, and then also tells us whether or not we are reading a certain chunk of bits or whether or not we are reading a certain number of packets. So that's what this bit here does. If it's a 0, we are reading the next 15 bits as the length of the chunk of packet, I guess, we're reading in. So basically we can read as many packets are there, but they have to be within that length. So we calculate the length here from the next 15 bits, convert that to our number. We log the start cursor, and then basically while our cursor, as it increments through the packets, while it is less than where we want to end up, just read the packets, and then whatever that packet returns back to us a number, whether it's through more math or through a literal, which you'll see later, log those numbers here, and then return them again. And then if the bit read here is a 1, we go through and we get the number of packets we should read in. We then read in that number of packets. Well, each time reading the packet in, we add it to nums, parse it that way. So all of these are basically just their logic. So sum sums up what parseOp reads. This does the product of all those, the minimum, maximum, greater than, less than. They're all just very identical. They're just doing different things with the numbers that are returned by this operation here. Lastly, we have the non-op code, which is the literal, which we're just parsing the literal. For this, what this means is we have a group of numbers, and we have the start number, which is the very first bit, is the kind of the start bit. So basically, while this start bit is a 1, we add on to our building literal here, which is what this builder here is for. Basically, while that start bit is a 1, keep adding on the next 4 bits of number to this growing binary number. And then once we reach the point where the start bit is no longer 1, we are at the last chunk of binary numbers to read, so we should read the next 4 and then convert that now big long string of binary numbers into a regular integer, or in this case long number, and return that. And that is it. So overall, a lot of code but nothing too complex. I was just very, very indecisive of how I wanted to do this. There we go. All complete. So again, hopefully you guys enjoyed. That is all for day 16 here. I'll see you guys tomorrow for day 17. Peace out.